Okay, this video is going to be about titration, and if you want to follow along from your book, this is problem number 1 from page 80B. And what is a titration? Well, the goal of a titration is to determine the concentration of an acid or base by measuring how much base or acid is required to neutralize it. So you're going to have either an acid or a base with an unknown concentration that you are trying to determine. In this case, we have acid down here, it's phosphoric acid, which is H3PO4. We have 15 mils of it, but we don't know what the concentration of that acid is, and that's what we're trying to find out. And we can figure out how much acid we have by figuring out how much base it will take to neutralize the acid in that flask. So the base is going to be, or your known solution, is going to be in your burette. In this case, our known solution is NaOH, sodium hydroxide. We know that its concentration is 0.2 molar, and the problem tells us that it took 35 milliliters of 0.2 molar NaOH to neutralize our 15 mil sample of acid. So from that information, we're going to be able to figure out how much acid was in that 15 mil volume in our flask at the bottom, and using that, we'll be able to find the molarity of our acid. So there are 4 steps that you are going to take whenever you are doing a titration problem. The first step is to write out a balanced chemical equation. So this is an acid-base reaction. So figure out what your acid is, what your base is, and neutralization reactions are double displacement reactions. So our base is NaOH, and we're going to react NaOH with our acid, which is H3PO4. It's a double displacement reaction, so the H is going to switch places with the Na. So the Na is going to go with the PO4, and the H is going to go with the OH. Before I move on, I need to double check charges. So sodium has a charge of +1, phosphate has a charge of -3. So the correct formula for sodium phosphate is Na3PO4, if you remember our little crisscross method that we've done in the past. After you've figured out what the subscript should be, then go back and erase the charges. Hydrogen is +1, hydroxide is -1, so no subscripts needed in this case. And you should recognize that HOH, 2 H's and an O, that is otherwise known as H2O. So you have created what we call a salt, which is an ionic compound, and water. So this solution right here is neutral. The way that we are going to tell that a solution has become neutral in an experimental situation is we are going to use an indicator. A common indicator used in labs is phenolphthalein. That's what we're using in the labs this week. And phenolphthalein is clear when it's an acid, and it's pink when it's a base. So what we want to do is to add just enough base to get your solution to turn very faintly pink. And that means that you will have added just enough base to neutralize all of your acid, and that will allow you to figure out how much acid you have. Okay, before we move on to our next step though, we got to make sure this equation is balanced. So right now I've got the products written correctly, but I haven't balanced it. So I need to go back and add in coefficients here and here. Now we'll have 3 sodiums on each side, we'll have 3 hydrogens, 3 hydroxides, so now we're balanced. Okay, step 2 is find the moles of known. So this step involves using your molarity triangle, so knowing that molarity is moles over liters. So if I want to find moles, I'm going to take molarity times liters. So there will be one substance, I should say, which you will know the molarity and the volume of. And it looks like in this case, the thing that we know the molarity and the volume of is my base. So that is my known, because I know the concentration of the base. So to find how many moles of base that I needed, I'm going to say 0.2 molarity times 0.035 liters. Make sure you take your milliliters, divide by 1,000 to get liters. And if you plug that in your calculator, you should find that it's 0.0070 moles of NaOH. So that's how much base it took to neutralize my acid. Alright, Next step is to find moles of the unknown. So I know how many moles of base it took. I'm trying to find how much acid I have. So I'm going to use this general format here. I'm going to take what I have, which is 0.0070 moles of NaOH. And I'm trying to find out how many, if I have this many moles of NaOH, how many moles of acid must I have? Notice how this is a stoichiometry question, right? I've got a balanced chemical equation. I'm going to need to use this mole ratio, that it's a 3-to-1 mole ratio, to figure out how many moles of my acid I have. So again, if you think back to stoichiometry, we use this technique called dimensional analysis, and we took the units that we have, multiplied it by a ratio of what we want over what we have. So in this case, we have moles of NaOH. I want to find moles of H3PO4. That is my unknown. And I know that it's a 3-to-1 ratio. So I'm going to say that since this is moles of NaOH here, on the bottom I'm going to write moles of NaOH. And what I want to find is moles of H3PO4. And this chemical equation tells me that I have 1 H3PO4 for every 3 NaOHs. So again, plug that in your calculator, 0.0070 times 1/3, you get 0.0023 moles of H3PO4. So now I know how many moles of acid were in the flask, but the question is asking me to find the concentration of acid. So this last step is again going to use my molarity equation, that molarity is moles over liters. And to find molarity of acid, I'm going to take the moles of acid, which is 0.0023 moles, and divide it by my volume of acid, which was 15 milliliters. I have to make sure to convert that into liters first. So my molarity is 0.0023 moles divided by 0.015 liters. So that means my concentration of my acid is 0.15 molar. So I was able to use the information that it took 35 mils of 0.2 molar NaOH to neutralize my acid sample to figure out how much acid I have and what the concentration is. And that's what I was looking for in this question. What is the concentration of my unknown acid?